Okay, welcome everybody. Great that you're here. 3 bite-sized talks of the 3 nominees of the Innovation Award. And we're going to start with Maqqie. So Kees, a big hand for Kees and Maqqie, and it's your stage.
Good. Hi, good afternoon. So I'm the CTO at Maqqie, and we want to unlock the full potential of the labor market in the Netherlands. So we believe that our collective workforce is stuck. Many industries have huge scarcity of people that want to work there. As you can see, the Dutch labor market is in crisis. 126 vacancies for 100 employees that are looking for work. And the Dutch trains, they have less trains, because there are not enough people to serve the trains, and actually now they started using Maqqie to find people for the trains. So we just had the first few people started working via Maqqie, so that's great. And also a problem is that flex workers, they are in a tight spot because there are dominant intermediaries that take a lot of the hourly rate, reducing in expensive people, resulting in expensive people and low wages for the flex workers. And there's a complex regulation system in the Netherlands with collective labor agreements, which makes it hard to innovate and to meet with the social trends that go on. So what people want is freedom to jump into chances, to have multiple types of work. For example, if a local company asks you to build your app and you don't want to start a company for the administrative overhead, so how can you get paid in a legal way? And also, if you want to combine things, you still want a paycheck every month, insurance for illness, job security. And what businesses need, so business want a flexible and adaptive workforce, high quality talent. So you want the best people on the right spot. Tomorrow can be different than today. Yeah, and what's the traditional HR players and disruptors. So what are traditional HR players doing? So do you know that lady? Did she call you this week or send you a message on LinkedIn? I have a fantastic job opportunity for you at another big consultancy firm somewhere in the other part of the Netherlands. And the disruptors, they have bicycle entrepreneurs. So bicycle delivery entrepreneurs that bring pizza to your home. Are they really entrepreneurs? Are they freelancers? Or is it just a platform that doesn't want to meet the regulations of the law and thus hire them as freelancers? And that is the transformation that we started. So what we want to achieve is a digital labor market that meets the flexibility requirements of this time of today, and at the same time always compliant and transparent, cutting down the costs of recruitment and security and flexibility for the workers. So we created the backbone of the digital labor marketplace. So we match people based on skills and career goals. Shops, hotels and restaurants, they can plan their shifts. So let's say there's a morning shift, afternoon shift, evening shift. They can plan the shifts and set skills on the shifts so that people can apply from the pool. And we pay the people, the salaries according to the laws, to the value that you deliver. And with that, matching is always easy. It is easy to plan people and to find the people, and it's always compliant. So we have implemented about 85 CAOs, collective labor agreements, to make sure that people are getting paid and get a type of contract that meets the requirements of the law. How does it look like? So, for example, this is the employer dashboard. There are 17 shifts planned for the future that still need employees. There's the contracting part. There are 3 contracts that have been signed by employees and still need workers, or still need to be signed by the company. So we have the process of looking at the hours that were submitted, declarations that have been submitted, and upcoming payments that will be invoiced from you. And of course, you can have your flex pool. As a company, you have a number of people working for you, and you can easily get in touch with them, invite new people to work. You can only get in touch with people you actually work with directly. Otherwise, you have to use our messaging system, and only people open to work can be approached. And what's our tech stack? So the platform was started to be built in Java like 3 years back, and 1.5 years back we started doing some Kotlin. And now all new initiatives are built with Kotlin. And we have about 15 applications running in the cloud, and we're using Kafka to synchronize data and send events between those applications. And this is our infrastructure. So we're completely cloud native with Google Cloud. We roll things out with Kubernetes and GitLab CI/CD. And we have a microservices architecture that makes it easy to scale both at runtime and also scale our development teams. Because the number of developers that we have, that's growing really fast. So 2019, we started having our own teams. Before that, we worked with external partners to do the development. And now we have 35 developers working for Maqqie from different locations all around the world, because it's not so easy to find all people in the Netherlands. Yes, and this is our revenue. So we first launched public in 2018, end of 2018, and now since then we have been tripling our revenue every year. So we have 2 kinds of work that you can do. So you can do payroll, which means like a permanent or a temporary contract, or you can use freelance with Maqqie. Yes, so, there's one thing I also wanted to say. Today we also have our nomination at the Deloitte Technology Fast 50. So that's running at the same time as this nomination. So we have 2 nominations on one day. So let's see what comes out of that. So our roadmap. So currently we have free and transparent matchmaking. This is what we have implemented. And now we're working on becoming an open platform, which means that all the solutions in the market, let's say a planning solution or a payroll solution or a freelance platform, they can hook into Maqqie via APIs. That's what we're working on right now. And after that, we want to work on guidance for your career path, which means that based on the work you've done at Maqqie and the things you want to become in the future, as we have lots of people in our database, we can give good suggestions with machine learning, AI, and data. That's our future plan. And our current rollout is that currently we only operate in the Netherlands. And it's not easy to scale this to other countries because every country has their own rules. They have their own collective labor agreements like things. And so next year we will start working on investigating all the countries, and then in 2024 we expect to launch in the next country, and we want to launch in all countries in Europe. So that's Maqqie. That's how we make work. So hop on a journey as well and create an account on our platform. And this is how we want to make work work. Thanks for listening.
Thanks so much, Kees. Are there any questions for Kees? Yeah, but you can probably hear me, right? Oh, you're trying to challenge me right now. Here we go, yeah? Yeah, you ready? Don't duck away, try to grab it.
Just wanted to hear, since you're doing this job market thing, working with developers from other countries, how do you handle things like their visa status and stuff like that?
They are working remotely for us. So they are not working in the Netherlands, they are working from India or Serbia.
And any that are here but are on a...
No, they work remotely. We have some people from India that migrated to the Netherlands, and those visas are handled, actually. So they're in this room too. So we know how to do it, because we also do that to get people from abroad to work via the platform at Maqqie. But
okay.
Yeah.
So if someone had a requirement for, say, developers that goes through your platform, would that then have to be a contractual arrangement between either you or the person who wants that, say, developer who is a foreigner in that case? Just as a
that contract would be between Maqqie and that person.
Okay.
Yeah. So and we have a fixed fee, which is all open and transparent. You can view it on the website, and that's it.
Okay. Perfect.
Any other questions? Any other questions? No? Okay. Thank you, Kees, so much. Big hand. Big hand.
Is this thing on? It is on, great. Good afternoon, everybody. My name is Nick. I'm a staff engineer at Adyen. I'm super excited to be here on behalf of my team. Some of them are sitting here. And I'll be presenting to you our newest payment method that we launched this year, Tap to Pay on iPhone. It's a brand new product that we built from scratch. And I would like to take you through at least one challenge that we faced. I'm sure that I'll get you excited. And if not, well, too bad. So, show of hands, who knows Adyen here? Great. Is it because of today, or did you guys already know it before? There we go. And do you also really know what Adyen really does? Show of hands, maybe? No. So yeah, there we go. So people know it from payments, of course. And at its core, Adyen is a financial technologies provider. We have a wide portfolio of financial products, but the most common ones, and I think the most relative for this talk, is the technologies that provide merchants to take payments, right? So that is what we do at our core. And that's what I'll be talking about today. So the two most common ones and the most relevant ones are online payments and in-person payments. They're kind of the obvious things that you think about when you think about Adyen. So when you think about your last Uber ride that you took from a night out partying, or that 20-euro sandwich that you bought at Schiphol when you're flying to some country with the tickets that you bought at EasyJet, those transactions we handled, moving money from A to B, right? So innovation never stands still, and these products that were once seen as revolutionary, they have now become traditional with the launch of our latest product, Tap to Pay on iPhone. Right. So this technology basically transforms any iPhone into a payment terminal, and fancy way of saying we are empowering our merchants to easily integrate with Adyen to take payments without the requirement of any additional payment hardware. So this is fantastic because any small to medium-sized business owner can basically transform their business, have an iPhone, and take payments without having this giant point-of-sale setup, which costs a lot of money and is difficult to integrate with. And we provide them with a solution that allows them to easily integrate with us. Right, so like I said, we built this solution from scratch within a year, which is an amazing feat if you ask me. But we had to make some smart choices. So one of the things that we ran into is how do we keep the speed, right? So not the speed in terms of performance, but how do we keep the speed in building such an application, building such a service? And one of the questions that we asked ourselves, okay, we decided to reuse the transaction logic that is inherently running on the payment terminals, which is written in C++. So we asked ourselves the question, okay, are we going to put it on the iPhone, on the phone, or are we going to move that to the cloud? Well, after a long debate, it was very long and very tense, we decided to eventually move the C++ code to the cloud, to our backend. There were some concerns regarding debuggability, maintenance, and the performance as well of running C++ code on the iPhone. It's not very trivial. So we decided to, make our lives a bit easier and move it to the back end. Obviously, there are also some concerns there, which I will discuss shortly. But all in all, we give our merchants an SDK. On top of that, they build their own application. And this SDK is then communicating with our back end, handling all the payment logic for them. So they build their application any way that they want, with any logic that they want. And we just do the thing that we're the best at, and that is payments. So, of course, putting C++ logic in our Java backend is not as trivial as one may think. There are some challenges there. So one of the first things that we thought about, all right, let's hook it up with JNI, use native interface to run the code embedded in our JVM. So some of you may think that's a terrible idea, and it was. That's why we did not do it. As you may know, C++ is an inherently unsafe language in terms of operations that you can do. If you access memory that you're not allowed to, your operating system will get mad at you and kill your process. In this case, the process is the JVM, and if a server is running in our case, our Tomcat application with our web app inside of it, the service just goes down, and that's the end of the story then. And in case if there's a malicious attacker or actor that knows about this, and you just have a couple of instances running, then stuff is on fire, and that's what we don't want. So we kept thinking, like, all right, so how can we mitigate this issue? So we had our good friends over at Oracle that told us about GraalVM, and especially the Enterprise Edition that has the so-called polyglot engine. This allows us to compile the C++ code to an intermediate representation, which is called LLVM, and the execution of that code is guarded. So any operation that you do, the polyglot engine checks, can I do this legally? If not, it gracefully handles it and throws an exception, which then we can handle ourselves as well. So this kind of made sure that we could run the C++ code embedded in our application without too much trouble. But of course, every upside has its downside, and that was, in our case, performance. One of the reasons our performance was not that good was because the LLVM is compiled just in time. It does so while optimizing the path of execution. So at some points, it would be a bit more performant, but there were some bugs in GraalVM because we were kind of the only company that was doing something like this. So ultimately, we said, okay, guys, this is not going to work. We did some benchmarking, and we could not sustain loads that you would expect in peak seasons, right? So long story short, we would not be able to scale to more merchants. We would not be able to scale to more transactions, concurrent transactions. So we decided to look a bit further, right? And we were thinking, okay, what if we were able to accept the risks of crashes somehow without bringing down the whole JVM? And I think that was kind of the idea that triggered more of the thinking of, okay, what if we have some sort of pool or orchestrator, right? So this C++ code runs on a terminal, and it's a pretty lightweight process. So if it can run on a terminal, then we can surely run a lot of them on some beefy machine with a couple of Xeon processors, right? So we decided to go down that road. We had a pool. We decided to have a pool of these processes, and with that, we would be able to have some buffer to mitigate the the risk of crashes and loss of service. And with that, we would be able to have some form of safety with the added benefit of native code execution. And we did that with something super simple. So solutions don't have to be complicated, right? So we did that with something super simple called the process builder. Some of you may have used it, some of you may have not. Well, in this case, you can use it, it's really cool. It's basically a way for the JVM to execute a process natively on the operating system. So we have a pool of these processes. With configuration, we can simply scale it up or down, whatever we want. And we use the thread pool executor to orchestrate them for us. So we're not building anything new or fancy. We're just using the libraries that we have in a smart way, if I can say so myself. So each process is a child of a worker thread, and these worker threads are then managed by the thread pool executor. If a process goes down, the thread gets killed, and the thread factory would then spin up a new process and a worker within a second, because these processes are relatively lightweight, so we can spin them up quite fast. We do the I/O with standard in, standard out, and standard error. So I mean, they kind of speak for themselves what they do. Standard in, we just send our request to the process. Standard out gives us the response back. It's very RPC based. And the standard error we use for logging and any exceptions that may occur. And yeah, so we would also be able to catch some weird deadlocks with some watchdog that we have, and then we would just kill the process and just restart it straight away. So one of the cool things is that we had some massive performance boosts. In the table behind me, you can see that when we use GraalVM, like I said, our performance was pretty terrible. The throughput was relatively low, and I think this table is, if you have a look, you can see that there was a pretty big change. The biggest one was the latency and the throughput. We would be able to handle 100 transactions per second, which is quite a lot. We don't even do that currently with our standard terminal fleet. So with just 8 workers on a single server, we'd be able to do 100. If you scale that up, I don't know how much we can do, but way more. So this improves shopper experience. It makes me sleep at night, especially with peak season coming up, Singles Day in China, and Christmas everywhere. So I go to bed thinking, okay, the server will stay alive. So I would like to share my learnings from this. If there is a tool to help you to launch your product fast, which we did within a year, use that tool. We used GraalVM. It made us launch our product really fast, but you got to stay critical when you're doing something like this, right? We made sure that all of our, we had a bag of tools, a bag of plan Bs and Cs, and we always reminded ourselves, okay, if this is not going to work, we still have other options left. And we launched, we were the first one, and then we said, okay, we cannot scale like this, so we decided to move to a different solution without breaking the bank or breaking our system. So with that, I would like to thank you for your attention.
Thanks so much, Nick.
Questions?
We have room for one question.
One question, yeah, sorry, it was a long-winded story.
Well, it was a great talk. So,
did you run into any hardware limitations on the iPhone? Because I know Apple is very close on the...
Hardware limitations on the iPhone. So we are in close partnership with them, and so I don't know if we ran into any hardware limitations, because they did open up their NFC reader, which is normally closed for anybody else, to specific partners. So we are one of those partners. So in terms of hardware limitations, we didn't run into any of those per se, except for the iPhones that don't have NFC reader, I guess. But other than that, we didn't run into limitations. Everything just worked out of the box.
So welcome everybody at our presentation about the photo adjustment project. You saw a little bit about it in the video, the talk before, and we will guide you through our setup. So what is Omoda as a company, and then Richard will tell you something more about the challenges that we faced during the project. So first, my introduction. I am Martijn, I'm a team manager at Omoda. Richard is a software engineer at Omoda. And well, that's very short. So this is a very long timeline, but I will guide you very fast through it. In 1875, the company started as a shoe company, and we delivered already home delivering the next day. So we were very technically high tech back then, but it still goes with the horse. Until generations further, we launched in 2000 a new Omoda concept. There was practically several shops around the country with all the same brand and with the same very luxury style. And we proceeded with that. And in 2007, we opened the web shop, one of the first retailers going online back then. So it was a big step for Omoda as well. And that go on for years. We built new web shops. There it is. And so 2021, last year, was a very big year for us as well, because we all those years, we only did shoes, but in 2021, we extended by, with clothes, and we also are now selling about 30% of all our revenue on clothes. So we grew very fast on that part, and that went along with some challenges. A brief introduction about our company. This is the main building. We have in-house marketing, in-house IT, in-house e-commerce. We try to do everything in-house. We have 750 employees. We have our own styling and photo studio. That was also where the project is about. And we have a large distribution center, also at the same location with a very large store location and fully automated packaging system. So we did already a lot of automation at Omoda, but not on the photo studio part. So that's what we're going to talk about. We have several shops around Europe. The most are in the Netherlands and one in Belgium, and we have 6 web shops in Europe. So when we launched this new concept last year to go into clothing, we thought we want to do this different than other competitors. Because if you have like Zalando or other shopping sites that you have, what is going to be the difference when you launch a new concept, and why would customers buy at your web shop? So what we did was, for each article that we sell is going to produce 2 or 3 outfits for that article. So, for example, this that I'm wearing is 3 times shot with different clothing. And for us software engineers, our hearts were beating faster when we hear that. But it was really cool that we have a different style to go live. And now we have 30% revenue in clothing alone. So that's, I can say, very successful in a year. So that is what we wanted to do. But if you want to, take all those pictures for clothing, we take them all by ourselves. We would need like 60 employees for the photo studio alone. So that was too big. So we have our current architecture here, and it's too detailed to go to every block. But the orange parts are the Java parts that we have. We have 2 Thinkwise applications. That is a low-code platform we are using for our ERP system. And the green one is the message queue from Google that we use to interact with all those applications. The website we have is not maintained by us. We have an external partner that is doing the e-commerce part, and that is run by Salesforce. And our IT team is around 20 people. So that's about a brief introduction about the Omoda concept and the general part. And I will give the word to Richard for the challenges that we faced.
Okay, heb ik hem goed? Oh ja. So this is the part where we are going to talk about is the product service and the media service. The talk is about the media service, which was built by doing this project. So Omoda is shooting around 20,000 articles per season. Every article has 3 photos, and every article has 3 different outfits, and they all need manual editing by the photo team. Here is, for an example, the jackets. You see the front, the back, and the zoom picture. You see here the different outfits with the same jacket but different product combinations. The problem was it took too long to get these online. It took 21 days to get an article online. So we were losing sales to other retailers, because if they have it faster online, the customer will buy it from them. Also, when the season started, external human resources were needed. So to handle the peak and all the clothing and to get it online as fast as possible. Also, the cropping was not consistent because when there are so many people working on it, they have all the different kind of opinions. And there was also turnaround in staff because the job got repetitive and boring after a while. So that's why our goal was to reduce the mistakes by manual cropping and automatically enhance the photos and automatically crop the photos. So first, we did automate enhancing the photos. We first tried to do it using open source tools like GIMP or other libraries, but the enhancements done by Photoshop were so advanced that we decided to run Photoshop. So the Photoshop team also has the freedom to change the action as they want. So we automatically apply these options with scripts instead of manually doing that. So here you see the result. In the left you see the old picture, and in the right you see the enhanced picture. You see only the background here is more light and some colors are brighter, but the screen doesn't show all the colors. Then we automated cropping, which was the hardest part. We had to analyze the photo using AI, and we did the cropping with Java. So first I want to talk about that no article is equal. It looks easy, but it is really hard because some articles have different heights. You have short jackets, you have long jackets, you have dresses, you have skirts, pants, shoes, all kind of different articles, and they all need different crops. Also no pose is equal, so the model can stand like this and the crop needs to be below the product, or if they stand like this, the crop needs to be below the hand. So we had to recognize some body features to do this. So we also had a challenge to detect the clothing within the outfit. We first tried using some manual training, but then we decided to go with the Google Vision API to do this. Here you see the different parts get recognized by Google Vision. The body parts were not possible using commercial APIs, so we decided to do that with open source tools. We use TensorFlow and MediaPipe to detect all the different body parts, eyes, eyebrows. Yeah, there is really a lot, and it's also working real time, and so it's really fast. Another hard problem was rotation detection. At first we thought we looked at the eyes of the person to know if they stand from the front or behind, but this is a back photo and the person still has two eyes visible, so we had to do some smart math to solve this problem. All the analyzing is done by our Analyze service. Here you see an example of different data from our Analyze service. The media gets uploaded to the Google Cloud Storage, and then with Google Cloud PubSub, the media service subscribes to the topic, and then the cropping begins. Here you see an example of the cropping being done by Java. You see the front, back, and the zoom photo. Here you see, for example, the function I was talking about the padding top and bottom of selection. So we had to recognize the hands or the bottom of the product. You see also functions show hands, wrists, and elbows, and then centering the hip horizontally inside the cropping selection. Another part was doing the zoom photo that had to work with all kinds of different hairstyles. So that was also a challenge. So we had to recognize where the hair started, where the hair ended, and things like that. This was another challenge. At first, we only had a bounding box of the whole person, but that wasn't enough to do the shoe crops, for example, because if a person is standing like this, the bounding box of the person is much bigger for that specific crop selection. So we had to detect it more specifically at eye coordinates, so we did that, and then in the right you see that we pick up the good x1 and x2, and then we apply it to our cropping area. Another challenge we had was, is this a dress or a skirt and a top? Google Vision thinks this is a dress, and so do I. But in reality, this is a skirt and a top. So luckily, we know from our product data that it needs to be a top and a skirt in this outfit. And we recognize that Google Vision recognizes a dress for this. So then we apply the max bounds to the dress. And we still recognize the lower part of the skirt well. This really works well for Omoda. Sometimes some things can be fixed, like for example, these poses resulted in a few null pointer exceptions at first because there were two, it was going outside the bounds, so we made some fail-safe, but these images it crashed after a month at work, so it was really easy to fix them, but still. Another thing we did was scoring the photos. We had lots of different crops, and we need to find the best picture, and we do the scoring based on the product visibility, based on if the eyes are visible or not, and all kind of other features. Finally, the photographer can select the results. We have a history with all the selected articles and outfits. We have a waiting list with all the upcoming items which they can choose from, or they can automatically click the Start Selecting button, and then we'll get outfit after outfit, after article, after outfit. They don't even have to choose then. Here you see the automatic suggestions based on the scoring. So for example, here you see a jacket product. This photo is cropped from the outfit image. It automatically recognizes the jackets and the body features, and it uses the cropping logic of the photo department to do the cropping. So the only thing the photographer here has to do is to click the orange button, and it will go directly online. We also have a fallback to manual selecting. So they can, in this example, the third photo has been chosen. We could even more improve this in the future, but it works really great for this our use case now. So the product is now online in no time. The development was done with small people. It's a small team of 2 people, and sometimes external help from for some difficult parts like the math functions and difficult stuff, really difficult stuff for if you didn't know something. It was developed in 3 months. We have no experience with AI. For the backend, we use Java, Spring Boot, and Python and MediaPipe and TensorFlow for doing the TensorFlow stuff. There were 6,000 lines of Java code written and 1,000 lines of Python code. The frontend is done in React, TypeScript, and React Query, and we do end-to-end testing with Cypress. So the benefits for the visual and styling team were enormous. We had 50% in cost savings, 7 days after arriving online instead of 21, with half as many employees on the visual and styling team, 3 times more articles. Already 15,000 articles have been done, and every article has around 40 pictures, so it really has worked well to now. So I don't know if there's any room for questions, but okay.
Any questions? Yep.
Will this software also be sold or shared with other companies?
How much do you want to?
I can think maybe can be interesting. Yeah, of course it is not so.
Yeah. Of course, at first we are a shoe company and a retail company, but we are so inspired by this project that maybe we are going to look maybe to make it open source or something like that. But we are not looking that direction yet. But it could be a very valuable product for competitors. So there is a chance that we go to the market with this. Our CEO also really wants to, but then you have to grow also as a team to to maintain it and other wishes that there are for other companies. But
do you have other AI ideas on how to improve the website?
Yeah, so we have some improvements of this process. The selection is still done slightly manually, so we could improve this even further by analyzing even more parts of the photo and detecting when the selection, we have now many selections being done by the photo team, so we know what they like, what is beautiful, what are beautiful pictures. So we could automatically learn the AI to select the photos even better.
Last question? No question? Oh, yeah. Just in time.
By using AI, you have the risk if you have more of the same. All pictures will look alike. Perhaps sometimes you want just an arty picture.
Yeah, I see. But there were some rules. The photos being taken are still the freedom of the photo team. So the problem we had at first was it was too random because of the poses. So we can do random things, of course, in the code, but you don't want accidental random things happening. We had it at first that we didn't detect the right person for the cropping box. Then we had random picture because sometimes it was like this, sometimes it was like this. But the photo team don't want this. They want really the same results, but the model can still stand like this or do all kind of poses, and the photos is still getting somewhere the same, but we could apply randomness to the photos if they want. But
yeah, and also what last week they told us we want to make more inspirational pictures. So now we have very standard poses, but what if we would take a chair and sit on a chair? So yeah, if we would run that to the code right now, I think it's going
they are already sitting on chairs.
But some things like that, objects that we don't recognize yet, we had to analyze the code again. What is it doing with it? And sometimes it's very funny what he does. But yeah, so we are constantly challenged by the photo team because now they can really spend more time on inspiration and less time on repetitive work. So that's cool to see.
Yeah, so we had a program crashing when the leg was the knee was below the person itself. So the index got around. So our program crashed. But they do crazy poses right now to just fool the AI. But it really works well.
What are you doing? You're sitting in the chair now? Big hand for Omoda.
Thank you.